Okay, this is the review for the last part of dealing with quadratics on factoring, completing the square imaginary numbers, and the quadratic formula. So the first four problems ask you to factor these. Because by now you would imagine that most factoring that you would do would be general factoring and not so much worrying about difference of two squares or perfect square trinomial because that is used in completing the square, so you kind of get it covered there. And you also, really in most instances, if it's a really, really complicated problem, you probably wouldn't bother to factor it anyway. You would probably most likely use the quadratic formula or complete the square. So in this case, these are what I would call standard general factoring. This is where you would want the problem to equal 0, so you can cancel this out. And then basically you're going to split it into two factors like this. And because this is a regular x squared here, we know it's going to be x and x. So now the rule is that the two numbers that we're going to put here and here multiply to give you negative 10 and also would add to give you negative 3. So you have to think about it a little bit. If you do, I think you'll find that it would be negative 5 and positive 2. Negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. And then really your answers are to say, what would it take to make this equal 0? When it's just a regular number like this, it's usually pretty easy. It's the opposite sign of what's in there. So the answer to this is x equals 5. This one is x equals negative 2. For this one, I would say it's basically the same idea. Again, you can make it equal to 0, but you really probably don't want that negative there. So just divide everything by a negative 1. And that will allow you to change the signs of each term. This one could actually be done by perfect square trinomial. But again, if we split it into two factors, we would say x and x. And now again, numbers that multiply to give 9 and add to give 6, that would be 3 and 3. So you can actually see how you get the same factor. So I would have said we should make this x plus 3 with a square on the outside of it. Then you get one final answer, x is negative 3. If we go on to the next one, we're back to even basic general factorings again. Same idea. Maybe you'll get in such a habit with these that you could do this without even really thinking about it. This one might be a little tougher. We've got two numbers that multiply to give negative 20 and somehow add to get 1. Well, you can think about the factors of 20 would be 1 and 20. That's never going to give you 1. 2 and 10 is never going to give you 1. How about 4 and 5? Wait a minute. Maybe if x is negative 4 and one of them is positive 5, that would be negative 20. And if you add them, you get 1. That's correct. X is 4. X is negative 5. And the last one is very much like number 67. Because again, we have that negative that should go away. So divide it all by a negative 1. We've got x squared plus 11x plus 30 equals 0. So we split it into two factors, x and x. Two numbers that multiply to give 30 and add to give 11. I'm thinking, well, let's see. What do we have? We have 1 and 30, 2 and 15, 3 and 10, 5 and 6, that's 1. 5 and 6. 5 times 6 is 30, 5 plus 6 is 11. X is negative 5, x is negative 6. Final answer. I would imagine by now that this general factoring stuff doesn't seem too hard after having seen all the other stuff we've done since then. Alright, these actually give you problems that are telling you to take the answers and return it back to the original quadratic equation. So this has kind of an interesting math skill. You can kind of deduce what you already have as an answer and follow the steps in reverse. Kind of a slightly more difficult thing. But if you think about it, what we're trying to do is go from the answers back to the factors, back to the equation. So how we had an answer that was the opposite sign of the factor, That's how we're going to do this. So if our answer is negative 2, that means our factor must have been x plus 2. And if our answer was positive 7, that means our factor must have been minus 7. Now you're going to use FOIL to put this back together. FOIL would be first terms, which are x times x, outside, which is negative 7 times x, inside, which is 2 times x, and last, which is 2 times negative 7. And in one step, we combine the like terms in the middle, and you end up with this as the final answer. Number 71 is the same kind of problem, but they try to make it a little harder because they give you some fraction answers instead of regular answers. The truth is that they aren't really much harder. They just take a little bit of extra work, unless you can spot the pattern. But basically what you're trying to do is make this thing equal to 0. So the first thing I would want to do is get rid of the 4 on the bottom by multiplying by 4. So I'm left with 4x equals negative 3, because these cancel. And then I'm just going to add the 3. So I have 4x plus 3 equals 0. When you get one of these things to equal 0, this stuff on the left is the factor. So that's one of the factors that I'm going to work with. So I mean, you can see it takes us a little bit of work to get to this stage before I even can use FOIL. But, you know, sometimes they take a little work when they're a little harder like this. Times 2, that's 2x equals 5. Subtract 5. 2x minus 5 equals 0. That means my factor is 2x minus 5. So I'm finally at the stage where there are factors. Now what I'm going to do is use FOIL to multiply it together. So first terms are 4x and 2x, that's 8x squared. Outside is going to be negative. Outside is going to be negative 5 times 4x, that's negative 20x. Inside is going to be 3 times 2x. And last will be negative 15, 3 times negative 5. Clean this up, combine the like terms. And you are done. Now we're on to solving these things when maybe they were a little tougher. It all depends. We call this completing the square. Completing the square means you're going to put a number in here, the C value if you want to call it that will make this thing easy to do a perfect square trinomial factoring, and eventually square root it all the way down to get a final answer. Completing the square formula is b over 2 squared. So b is the number that's next to x. So in this case, the number we're going to put in here is going to be 10 over 2, that's 5, squared is 25. I'm going to add a 25 in here. And because I added it here, I've got to add it here. So that's 45. So when I figure out what number goes here, I know the factoring will always be the same. It's going to look like this. Square root of this, the sine of this, and the square root of that. So then now I'm going to get rid of this square by square rooting both sides and allowing that to cancel, and I'm down to just x plus 5. So I went from all of this down to just x plus 5 in really one step. Square root of 45, that can be split up. Square root of 45 breaks into the square root of 9 and the square root of 5, and that's 3 square roots of 5. So plus or minus 3 square roots of 5. And now I'm just going to subtract this 5 away from both sides. Put it first, not part of the square root. That second, and since I can't simplify it anymore, this is done. So number 73 has the same basic principles involved in it, but it starts out a little bit differently. As you can see here, what we really want, we already have in this problem, which is to say the x squared and x terms are together, and the regular numbers on the other side, and there's nothing to simplify out. here right away I would say you could divide everything by 2, so you should do that. That's going to be x squared equals 4 plus 6x. And then I don't want that 6x there, I want it over here with the x squared, so I subtract it away. And now I got x squared minus 6x equals 4. So with that, then I'm going to say, okay, now I'm ready to complete the square, so I got to add a number in here. Negative 3 over 2, or excuse me, negative 6 over 2 is negative 3. But when you square that, it's going to be positive 9. So what I have is x squared minus 6x plus 9 equals 13. And again, I'm getting it from this idea. Negative 6 over 2, that's negative 3 squared, positive 9. Add it here and add it here. Okay, I can do perfect square trinomial now. That's going to be x, the sine of that, and the square root of that. Now I can square root to cancel out the square. Okay, square root of 13. I can't do the square root of 13, and I can't split it either. So it's just plus or minus square root of 13. And I'll add 3. Again, don't add it to that. Put it in the front. You have a final answer? So sometimes you can't do anything with the square root. It happens. All right, these are also completing the square problems, but these involve imaginary numbers and complex solutions. Not really any different. It's just a matter of, really saying, well, can I follow the same steps and just know that somewhere along the way I'm going to get an imaginary solution out of it? It would start out as equaling 0. And again, I don't want this number here. I want it over here. So I subtract it off, and I'll make this step now. So really what I got to figure out is what number does belong in there. Again, I'm using b over 2 squared. So negative 6 over 2. Negative 3 squared is positive 9. It means I'm going to add a positive 9 in here and to this, which would make that negative 11. Perfect square trinomial factoring. X minus 3 square root, cancel the square, x minus 3 equals, okay, here we got 11 that I can't do the square root of and I can't simplify, but the negative I can take out. So I'm going to do plus or minus square root of 11, and the negative means the imaginary unit. Add 3, again, in the front, because now you're dealing with an imaginary unit. You cannot combine those at all. That's your final answer. For this one, same idea. Start at set equal to 0. Subtract the 3 because you don't want it there. Now we're going to do b over 2 squared for this. b is negative 2 divided by 2 is negative 1. And when I square it, I get positive 1. So I'm actually going to add a 1 in here. So it'll be x squared minus 2x plus 1 equals negative 2. Perfect square trinomial factoring. X minus square root of 1 is still 1. Square root everything to cancel the square. X minus 1. Again, can't do anything with the 2, but I can take the negative out. Plus or minus square root of 2 with an I. Add the 1. 1 plus or minus square root of 2 with an I. Final answer. Notice that the I, in either case, is not under the square roots because you're doing the square root of negative 1, and that's equal to I. So it should not be under the square root anymore. Make sure that you write it outside of the square root. Okay, last and not least, we have the quadratic formula. Gotta fix something here. Okay. All right, the quadratic formula is written on your review paper, but in case you happen to not have it with you at the moment, the quadratic formula is this. Negative b plus or minus square root of b squared minus 4ac, all of that over 2a. So for each problem, you basically need to know what a, b, and c are, and then you're good to go. A for here is the number next to x squared is 3. B, the number next to x is negative 10. C, the number by itself, is positive 4. So you got to plug all that into that formula. So x is negative, and then in parentheses, negative 10, plus or minus square root of b, which is negative 10 squared, minus 4 times a times c. All of that over 2 times a. So in one step, you can kind of clean all of this up. You're going to get 2 negatives, make that a positive 10. And under the square root, we've got negative 10 squared, that's 100, minus, and then 4 times 3 is 12, times 4 is 48. 100 minus 48, that's 52. All of that is over 6. So the square root of 52, you can split that up. This is a little work on the side. Into 4 and 13. That means 2 square roots of 13. So what you have is 10 plus or minus 2 square roots of 13 all over 6. And now, the only thing left is if you can, you should divide it. If you can't divide, you should at least try to simplify or reduce it. If you know that 2 goes into all of these, so you can do that. So here, the last thing you want to do is reduce it. If you notice, you can take 10 and divide it by 2, 2, and 6 all go by 2. So you can say, all right, if I divide it by 2, then that 2 would actually cancel, and I'm left with just the square root of 13. And this one goes down to 3. And that's the final answer. The problem with this quadratic formula is you really never know what you're going to get as an answer. Sometimes you get stuff that is, really down to just normal numbers. Sometimes you get things with imaginary units. Sometimes you get square roots you have to simplify. Sometimes you get square roots you can't simplify. Who knows? So, you just kind of got to take it for what it is. Make sure that your starting point is correct, and then just simplify it as far as you can go. All right, let's look at the last problem. First off, this negative 4x doesn't belong here. It needs to be over here. So I'm going to add 4x. So I got 2x squared plus 4x plus 7. And now it's equal to 0. To use the quadratic formula, it's got to be equal to 0. I forgot to say that over here, so technically this is equal to 0. This one wasn't set up as equal to 0, so we had to make it that way. But now it's ready to go. So a is 2, b is 4, c is 7. So using the formula, negative b squared minus 4 times a times c, all over 2 times a. Clean up step, negative 4. Okay, in here I got 16 minus, let's see, 8 times 2, or 4 times 2 is 8, times 7 is 56. We get 16 minus 56. That's negative 40. So maybe right there you can tell you're going to end up with a complex solution over 4. So can I split the negative 40 if I can? If I can't do that square root, can I split it? I would say yes. The only thing is 4 is the biggest one, so it's going to be 4 times 10. Plus we know we have that negative in there, so it's really 2 square roots of 10. So when we simplify this right now, I got negative 4 plus or minus. Let's see, I got 2 square roots of 10 with the I, because it is negative, all over 4. And here again, if you can't divide, you should. If you can't, you need to at least, reduce it. Some people argue that you should divide the negative 4 and 4 and then leave this as something over a fraction. I say leave it all over a fraction, but reduce them. 2 goes into all of these. So I got x equals negative 2 plus or minus. That 2 will cancel, leave me with square root of 10i, and then all over 2. And that's your final answer. So that one had a bunch of stuff in it. Simplifying the square root, an imaginary unit, reducing the fraction, all that stuff. But sooner or later you get there. All right, so your test for part 1 is on Tuesday.